All right, part 2. So number 25 is asking what direction is the current if you have a magnetic field that's X's, which is into, and then O's, which is out of. So I'm looking for the direction of my thumb, the current. I know my fingers are going in on this side and coming out on this side of the wire, if you want to use like your pen. So going in on this side, coming out on that side, that leaves your thumb pointing to the left like this. So answer is A. Which compass has the correct, pointing in the correct direction? So first, let's look. We have positive and negative terminals. Current is coming from the positive towards the negative, so that means that it would be going up on the front right here. No, not all of them are the same. This one is going to the left, but then that's around in the back, going down in the front. This one is going up in the front. This one is up in the back, down in the front. Now that we have the direction of the current, we can find what type of poles are created. So I've got a thumb up. That means the side, whatever side my fingers are pointing in on, that's the south pole. So this is my south pole, north. Thumb down, my fingers are pointing in on this side. That makes this the south, this the north. Thumb up, pointing in here. Thumb down, pointing in on this side. And then now that we have the poles, we're just choosing which of the compasses is pointing in the correct way. So here it has, that's the north. It has north pointing to north and south pointing to south, but like poles repel each other, south would be pointing to north and north would be pointing to south, so it's C right here. Direction of the force, I'm looking for what my palm is doing. I know that the direction of the charge, my thumb is pointing up. And fingers, so the magnetic field points out of north and into south, so my fingers, or the field, is pointing to the right. And then this is negative, so that means use your left hand. So I'm going to use my left hand, make my fingers point this way, but I need my thumb pointing up the page, so that leaves my palm facing out of the page, and that's your answer. Direction of the force, so the magnetic field is pointing out of the page, circles mean out. The thumb is pointing up because that's the direction the charge is moving. We are looking for the force, so my palm. So fingers out, thumb up the page, that leaves my, this looks so weird, that leaves my palm facing to the right. To the right. Here, direction of the magnetic field at point P, so X means into, so my thumb, my current is going into the page, my fingers are curling around like this, so that's clockwise. At point P, clockwise is directly to the left, so to the left. The field in general is clockwise, but at this point right here, clockwise is to the left. Direction of the magnetic field at point P, so this is negative, electron current is going down, so that's my thumb is pointing down, and then if you imagine the pen is like your wire, on this side of the wire, my fingers are pointing into, they'd be coming up, so it would look kind of like this. So at point P, those are terrible circles, at point P, that's into the page, so C. Which of the compasses are pointing in the correct direction? So our rule is out of north and into south. So if we look at this, we want to come out this way and go in this way. So Q is definitely correct. I want to come around and go over to go back in the south. So P is correct. To go around to go back in the south, R would have to go this way. So R is not correct. It's just P and Q. So this one, that's a C, by the way, P and Q. What are the different poles? So Y, it says it's pointing out of, so if your magnetic field is pointing out of Y, it points out of north and it should be going into south, so this can only be a north pole because it's pointing out of. Given the magnetic field entering given the particle entering the magnetic field, it feels a force down, so that feels a palm down. Fingers are going into, because that's X's, and your thumb is pointing to the right. So if I have fingers in, thumb this way, that leaves my palm facing up. That's incorrect, so let's try my left hand. Fingers in, thumb to the left, that leaves my palm facing down. It means it works for my left hand, so if it works for your left hand, that doesn't look like hand, but works for your left hand, that means it's negative. If it had worked for my right hand, then it would have been positive. Direction of the magnetic field in the center. So first, your current is going up in the front, so thumb up. That means my fingers are pointing in on this side. So that's my south pole, that's my north pole. It's going in here, it's coming out here. So in the center, it's coming in, going out this way. So it's pointing from from C towards A. So towards A, to the left. Electron, so make sure you use your left hand. Enters magnetic field. It is deflected to the right. So that means it feels a force to the right. In what direction was the electron entering the field? So first of all, force or palm is to the right. The magnetic field is my fingers, and they are circles, so my fingers are pointing out. I'm looking for the direction the electron was moving. That's the direction the charge is moving, so I'm looking for my thumb. So electron uses left hand. I've got my fingers pointing out. I need my palm facing to the right, which it is, and that leaves my thumb pointing down the page. The motion of the magnet shown would induce the current, true or false. So let's look. This has current pointing down in the front. That makes this my south pole, this my north pole. If you have a north pole right here, these two are repelling. So north and north repelling. You would have a pole created that would repel if you were pushing into, so that is true. If you were to pull away, that would try to attract back, because it always wants to do the opposite of what is happening. If I tried to pull away, attracting would create a south pole here, which would mean current would be induced up. So the current induced down is a north, that's repelling, so yes, it was pushed into like that. Ball A has mass 3, is moving to the right at 8, and then this one has mass of 2, is moving to the left at 6, so I need to put a negative sign, because the sign absolutely matters for the momentum equation. And then they stick together, and I want to know the velocity after. So for a collision, we use conservation of momentum. So M1v1 plus M2v2 equals yeah, okay. So the before we already have right here, 3 times 8 plus 2 times. What we need to be careful with is this is going to the left, so it has to be a -6, otherwise you get wrong answers. Then they're going to stick together. So my after picture, I'm looking for its velocity. I don't know what it's going off at, but I do still need to know the masses are 2 and 3. And then because they're stuck together, those are the same velocity, so I'll just call it V. On this side, we've got 24 and -12, so that should be +12. Yeah. And then 2v plus 5v, or sorry, 3v plus 2v is 5v, and then you just divide your velocity, or 5 over, that gives you a velocity of 2.4, and it's +2.4, so that's going to the right. Which interval is it moving forward at constant speed? Here it's at rest, so not this one. Here it's going backwards, so not this one. These two are both going forward at constant speed, so 0 to 20 and 40 to 60. C. Box has mass 12 kilograms. It has a applied force of 100 newtons and a friction force, so the opposite way of 20. So first, my net force is going to be 80 newtons. F net equals MA. 80 newtons equals mass of 20A. Now you just divide over and you get a acceleration of 6.67. Which of the following is true? At point W, it has maximum potential energy. That is definitely true because potential energy depends on height. And at point X, it has minimum kinetic. Actually, no, that's not true. At point X, it should be like maximum kinetic. So here, I'm going to say this is potential energy, this is kinetic, this is both. This is like mostly kinetic energy. Because at the bottom you don't have potential, that means it goes into kinetic. So let's look. W is a minimum potential. No, it's like all potential. W is a minimum potential. No. W is a maximum potential. Yes. X is a maximum kinetic. Yes, we agree with that. We want a sound that has the same pitch, so it's equally like spread out, but it gets quieter, which means that it loses amplitude. So it goes from like tall to short. So the only one that is getting quieter is this one right here. This one got higher pitched and louder. This one is keeping the exact same volume, but getting higher pitched. Shortest wavelength, so let's mark off A. This is the wavelength for A. C, the whole thing. Wavelength for C. B is also this one right here. right? One wave like this. And then D is also the same as C, so wavelength of D. So the shortest wavelength is both A and B. They have short right here. The quietest would be like the least tall one, so B is the least tall one. A and C are both loud compared to B. Lowest frequency is the longest wavelength, so the longest wavelength is C and D. Period is 5 seconds, so just go ahead and mark that that's your capital T, the time for one wave. The amplitude of the wave is how tall it is, so that's 2 centimeters. The wavelength, how long it is, so that's also 2. That's just one wave. The frequency, so frequency is just 1 over period, so 1 over 5 seconds gives me 0.2 for my frequency, B. Speed of the wave, so V equals F wavelength, frequency we already said was 0.2, wavelength is 2, so that gives me 0.4. Oops, I meant to not have that in centimeters. Oh. A and B are sound waves. How do they sound different? So they look like equally as tall, so they should be like the same volume. It's not getting quieter or louder because it hasn't gotten taller or shorter. So you can cross off those. Now A, or I would say B really, is more squished together. So more squished together is a higher frequency or a higher pitch. So that means this one has a lower pitch because it's more spread out comparatively. So A is a lower pitch. Speed of the wave, if the period is 0.33 hertz, okay, that's a mistake. So I have 6 meters, that's not my wavelength, that's the length for 3 waves. So 6 meters divided by the 3 waves gives me the length of one wave is 2 meters. V equals F wavelength. So this was a typo. What did I put for the answer? It says the period is 0.33, but then I have the unit for frequency, so that was just a mistake. That was supposed to be 0.33 seconds, my bad. So that's my period. So then frequency, you just do 1 over the period, so 1 over 0.33 gives me a frequency of 3 hertz. And then now you just plug in V equals frequency of 3, wavelength of 2, so that gives me a speed of 6. My bad, I promise I won't have something like that in the exam. And if there is, you just raise your hand and ask. A wave generator located 4 meters from the reflecting wall produces a standing wave. If the speed is 10, so that's my velocity, what is the frequency? So V equals F wavelength. We know the velocity is 10. We're looking for frequency. We need the wavelength. So if you look, this is not the wavelength. That's the length for 2 waves. So 4 meters divided by the 2 waves gives me the length of 1 wave is 2. So then you just divide over, that gives me a frequency of 5. This diagram covers a distance of 8 meters. If the wave travels at this velocity, then what's the frequency? So V equals F wavelength. Velocity is 1.33, looking for frequency. Wavelength we need to find. So I have the distance for 1.5 waves, so I'm going to divide the 8 meters by 1.5 waves, and that gives me a wavelength of 5.33. So substitute that in for wavelength. I'm going to divide over 1.33 over that. That's going to give me a frequency of 0.25. High-pitched sounds, they're real squished together, so they have a large frequency, because pitch goes with frequency, and they have a small period and a small wavelength. Those are both going to go together, because we know that period is 1 over frequency, so if I have a high frequency, dividing by a big number makes it small, and also if you're squished together and you have a short wavelength, those go together. The speed is going to be constant, so we can cross off these ones. That doesn't have any dependence on the pitch. And then the amplitude has to do with volume. You can be high-pitched and loud or high-pitched and quiet, so we can cross off the amplitude ones as well. And then the answer is C, because I said big frequency.